let us start. Or should we wait for more time? What is your suggestion?
Sir, we can start.
Let's start. So let us start. So this is seventh experiment, and what we have learned since beginning is following the same. First it was soil properties we have learned, and then measurement of water by weirs and notches. So we used weirs for our experiments, and then it was to find out the flow discharge or discharge in pipeline. So measurement of discharge or flow in open channels and pipe. That was basically measurement of water. Now it is designing of a conveyance system. Conveyance means either it's a pipe design or it's open channel design of most economical section. So we have picked here pipe design. So previous experiment was measurement of discharge in pipeline by using Venturi and orifice meter, and now it's a conveyance system design of a pipeline. Pipeline means what size of pipe we should pick so that losses of head or head loss is minimum. So this experiment is based on that idea, and I sent you the write-up to find out fraction factor for pipe of different materials, or sorry, different diameters here basically of the same material. So it's a major head loss. How much head of water will be lost if we are picking a certain diameter of pipe? That depends on friction factor or coefficient of friction. We have already discussed in theory class, but once again, let me tell you. So have you gone through that write-up I sent to you? Anybody?
Yes, sir.
Any query?
Yes, sir.
Any query based on that write-up? You couldn't understand? That I know. Anyway, okay, let me explain it once again. So it's to find out the friction factor of a pipe of different diameter but same material we are using. Basically, this is a design which size of pipe we should take so that it is not developing or creating head loss more than a certain limit. So size of the pipe we can design to supply water. So here in this experiment, we have 5 different diameter pipe of same material, 15 millimeter, 20 millimeter, 25, 32 and 40 millimeter, right? And arranged in a such way that supply of water is there with varying discharge conditions. Suppose these are the pipes connected from a pipe, and this is water supply 4 and this one more 5. And at the outlet, they are connected in such a way to connect any discharge they are bringing. And we are measuring this discharge from each and individual pipe. I can show you just one figure here, which is relating to this, like this. So we have supply of water here from this side. We have pump from a tank here. It is connected, supplying water individually. It's a collection tank from individual pipe of different dia. We can measure by using a stilling vessing arrangement what is the height of water in this fixed dimension tank it is collecting in a particular time t to find out discharge per unit time. If we measure the head loss at a certain length of pipe, right? That we can measure by using U-tube manometer arrangement here that is connected to each and individual pipe. We can use the Darcy-Weisbach equation. If you recall in theory, I told you head loss due to friction is simply FLV square by 2GD. If you recall, we discussed this. F is the friction factor. When it is some books, it is written 4F, LV square. Sometimes if you have gone through, then this 4F is basically F, there is a friction factor, sorry, coefficient of friction. So this is friction factor. Now, this idea is used to find out the head loss due to friction in the pipe of a particular material, but different diameters. So we have U-tube manometer connected for each pipe here, and we have a water collection tank. If you recall earlier, it is 40 centimeter by 40 centimeter tank, and we are observing how much time it takes from here, a certain height of water in this tank, to another height, suppose 1 or 2 or 5 or 6 to just 10 centimeter. So in 10 centimeter collection of water in this tank, how much time it is taken, we can find out from their discharge. So theory, if you recall, in theory class as well as your fluid mechanics, you have learned that based on the observations, experimental observations, frictional resistance of flow is simply proportional to the velocity of flow to the power n, where this n, that is a constant, varies from 1.72 to 2. Frictional resistance is proportional to the contact area, means size of the pipe. Also, characteristics of fluid, that is density. Here we are using water, but any fluid which is having different characteristics than water, so density will affect this flow condition. It's independent of pressure, no matter at what pressure it is flowing. It's not matter. It is slightly affected by variation in temperature of flowing fluid that affects the friction condition or viscosity condition. So a little bit slightly it is affected because of temperature, and it depends on the nature of the surface of this contact, whether it is a smooth surface or it's a rough surface. So once these observations are put into theory, we are getting this Darcy-Weisbach equation, which states that head loss due to friction in pipes flowing under turbulent condition is simply equal to the F, that is the friction factor, L, that is the flow length from where flow is passing through in this pipe, and V is the velocity of flow, divided by 2gd, where d is the diameter of the pipe in same unit. So head loss due to friction may be in meter if every corresponding unit we are using in meter and second. You know that velocity is simply equal to the discharge per unit area. So if you are transforming this from here, velocity and area is equal to the pi d square by 4. D is the diameter of the pipe. Then we can find out simply F, that is our target friction factor. To find out friction factor and balancing this, if you are putting here head loss due to friction will be equal to FL, B square is equal to Q square, simply Q square by A square at the bottom. So 2GD into A square means pi square d to the power 4 divided by 16. So if you are balancing this, 16 will go up, 2 is here, so it will be 8 FLQ square divided by GD, G pi is as well pi G into d to the power 1, d to the power 4, so d to the power 5. So head loss due to friction will be equal to 8 FLQ square when we are using Q divided by pi G d to the power 5. And to find out F, we can balance this. F is equal to pi G d to the power 5 divided by 8 LQ square into simply HF. So that is, it is written here. Oh, pi square as well, sorry, here as well pi square. So it's pi square G d to the power 5 8 LQ square into HF, that is. So our target is to find out head loss, measure the head loss due to friction first in the pipe, And from that, we need to find out what is the friction factor of that particular pipe of that certain material. Then you can compare whether changing the diameter will affect the friction factor value of the pipe. By measuring head loss, that is, we are measuring by using YouTube manometer. Diameter of the pipe is known to us. We know the value of G. We can find out what is the flow path or flow length, means size of the pipe, and discharge we are measuring by using the collecting tank and stilling basin arrangement. So this is our target, to find out a suitable dimension or diameter pipe where head loss is least if we know the friction factor. So I hope you have gone through the methodology. So dimension as well as means dimension as diameter and length of the pipe we need to first find out, then we need to measure the discharge of flow. So it's a step-by-step methodology, and finally we need to get the observation to find out the diameter of the pipe, length of the flow in the pipe, area of the tank. We can find out what is the size of the tank, length into width. So we can find out height, that is collecting discharge height in a particular time t to find out the discharge. And material of the pipe we need to write down here. Observations we are collecting for YouTube manometer, left limb, right limb, means one side it is inflow side, that is high pressure, so it will be always lesser, and outflow side the pressure will be less, so it will be at higher side. So we can find out, somebody was asking 12.6. Is it clear to you or not? Multiplier by 12.6 to make the head of water equivalent of this mercury. Is it clear? And if it is not clear, then I can once more explain here, or I believe that in theory we have discussed, but if still it is not clear, you can ask. Then in collection tank, tank size we know. So we are simply measuring or say recording initial height of water in this tank and final height of the water in tank in a particular time t to find out the discharge. Once we have this head difference, that is HF, head loss, we know the discharge Q, we know the diameter of the pipe, we know the length of pipe from where flow is passing through. To measure the head loss, we can find out the friction factor here for different diameter pipe, for different discharge condition, and then we can average for each diameter pipe to find out the average friction factor of the pipe for all the observations. And at least this is 5 readings should be taken for each of the 5 different size pipes. So this is the simple idea to decide or to take, means decision what size of pipe it should be there to avoid the friction head loss or head loss due to friction in the pipe flow, and what material as well, because F is known to us now. Is it clear? Then you need to plot the graph between discharge and corresponding F value for each pipe diameter. Is it clear?
Sir, I had one doubt.
What is that?
Sir, in practical application, there must be some settlement of minerals inside the pipe. So friction factor will be changing.
No, it's usually no, because it's a turbulent flow. So it's a no deposition. It's not mineral, but it may be, you can say, silt or clay material, clay particle you are telling, right?
Yes, sir.
So it is flushing because it's a turbulent flow. This equation is for pipe flow where it's a turbulent region condition. In turbulence, it is not possible to get deposited for longer. It is resuspension and passing. But certainly, it's a corrosion in pipe. that will change the friction factor with the time of the pipe. And that's why that is called the shelf life of a designed system. After certain years, we need to change this. Or whenever it is more head loss it is generated, we need to change this because that requires more energy to supply the liquid. Is not that?
Yes, sir.
So that is simple idea. If it is a simple, there are three types of flow in pipe condition. What are those? Laminar, then
Turbulent.
turbulent, and in between there is one. What is that called? Transition flow. So laminar flow, transition flow, and turbulent flow. How it is defined? Based on Reynolds number. Theory last week only we covered. So laminar flow defined that if Reynolds number is up to 2000, somewhere it is written up to 2200, maybe means something like this, 2000 or 2200. If Reynolds number is within this range, it is laminar flow. From 2000 to 4000, it is called transition flow. And if it is more than 4000, it is turbulent flow. So usually in pipe flow condition, when pressurized flow is there, it is more than 4000. So it's a turbulent. So any clay particle 0.0002 millimeter particle, it is not getting deposited, but it's in turbulent. So automatically it will go off. But sometimes system is off. So any corrosion means molecules are attached with the surface of the pipe with the time. That will certainly change the friction factor or frictional value of this pipe material. And if it is changing more than a certain limit, we need to change the pipe to avoid any energy loss to supply the water or any liquid in that pipeline system. Did you get my point?
Yes, sir.
Any other query? Any other query? If no, then I have loaded a file. I have uploaded a file in your files, general class material, and that is experiment number 7. It's video. It's for 15 minutes, and remember, the observations are taken there in this video. You need to write down, you need to record, because I'm going to give you the observations, but observations are not given for this video conditions only. There are 5 diameter pipes, 15. What are those? 15, 20, 25, 32, and 40 mm. So observations are given for 15, 20, but not for 25, because 25 millimeter pipe diameter is taken in this particular video observations video. So you need to listen it carefully and record the observations. And I will put the observation table for remain. So you need to record the observation, write down the observations for this video, put there, and go for your friction factor calculation for these 5 different diameters of the pipe of same material. Is that clear? Students?
Yes, sir.
Okay.
Yes, sir.
So can you see whether file is available, video file is available? That is experiment number. So you please watch this. That is for 15 minutes. It is 2:55. We will meet at 3:10 again. I will give you the. This is the apparatus. Pipe friction apparatus, it is mentioned as well. So this is where we can measure the friction factor of any material pipe. This is apparatus, to find out the friction factor of steel pipe. So we have, as I told in the class, 5 different size of the pipe: 15 millimeter diameter pipe, 20 millimeter, 25 millimeter, 32 millimeter and 40 millimeter. So we have 5 diameter pipes which are getting supply of water through a pump source, and it is connected here. So each pipe is getting the water supply for all 5 diameter, and it is managed by the gate valves. At the outlet it is arranged. So once water is supplied to any one of the pipe, if we open it, it is getting the only one pipe which is opened through its gate valve. And discharge we are measuring by collecting this water through this tank, which has a particular dimension. You can see here, size is 40 centimeter by 40 centimeter, exactly 40 centimeter, and we can measure what is the flow volume per unit time. So if we observe the discharge from any of the pipe for a certain height of discharge or flow that is collected in this tank, so per unit discharge we can find out. Once we have this discharge per unit time, we can use Darcy-Weisbach equation, which states that head loss due to friction is equal to FLV square by 2GD, where F is friction factor, or we can have 4FLV square by 2GD, where F is coefficient of friction, and B is the velocity of flow. So velocity of flow we can find out simply discharge per unit area of the pipe. So we know the diameter of the pipe, we can find out the area, and in this way by balancing we can find out what is the friction factor by using this Darcy-Weisbach equation. So what we need to do, we need to find out L, length of flow, B in terms of discharge per unit area, G we know, diameter of the pipe we know, and head loss if we can measure for different flow or different discharge condition, we can find out the head loss due to friction by measuring the same in using this U-tube manometer. So this U-tube manometer, just like you have already learned in your fluid mechanics, we have supply of water which from the both sides, from inflow side and outflow side of the pipe. So length we can find out by measuring the different in length of these tappings in the pipe. So tapping is at the same length in the all 5 diameter pipe. So let us find out what is the length of the pipe. Here it is 1 meter. Let me show you. 2 meter, and from here, let me this from here to just here, 2 point from here 2.4 meter. So length of tapping is 2.4 meter for all the pipes. Velocity we are getting from discharge per unit time relationship. G we know, 9.81 meter per second square, and diameter of the pipe. So let us find out at least for 3 different discharge condition what is the flow and head difference for this 2.4 meter difference from inflow side to outflow side, that we can measure by using this U-tube manometer, finally to find out coefficient of friction or friction factor of the pipe. So let us start this. Okay, so now let us take the observation for 25 mm diameter pipe first. So pump is supplying water to this 25 mm pipeline, because its flow is open there. And to measure the difference in head by using U-tube manometer, we open this stacking from this side. This is inflow side. This is parallel to this pipe, so it is open. And at the outlet side, it is open. Now it is open, parallel to this. Perpendicular means long. And supply of water, it is going through this 25 mm. That is 15, 20, 25, 32 and 40. So 25 is now working. Now you can see at the ideal condition when there is no supply of water or no pressure difference is measured because it's open, but here it is closed. This is closed, so no supply of water from inflow side or outflow side, so no pressure, so almost same head for both sides. So let us see the head difference for this first pressure, and let us see whether there is any air lock or not inside. So remove any air lock, so we can see water is supplied from both the sides, so it is no air lock. Now let us close this at the same time to find out what is the head difference. So let us see, this is supply side, head is, this is 19, 20, so we can see this is 20, 19, 19.4, so 19.4, and this is 25, so 25.2, 25.2 and 19.4, that is the first discharge condition. And now let us measure what is the discharge per unit time. So volume of water for a certain time, let us measure in the tank. Now let us observe this, what is the discharge per unit time. So we are transferring this flow to this measuring tank, and here we can see the flow. The moment it is coming from 1 to 11, just 10 centimeter rise in head, we will observe. Rise is starting, so let us start 1. So starting from 1 to 11, let us see how much time it is taking. Yeah, it is coming. 9, 10, and now it is 11. So it is 20.72 seconds. It takes to rise now 10, then this out, draining back. So let us keep this tank dry or empty, so that another observation we can take, at least 3 observations for each head we are taking to average out the correct information. So let us start this time from. So let us start this time from 5 to 15 to find out how much time it takes to rise 10 centimeter. So the moment it is coming, yeah, 6 from 6 to 16. Yeah, it is 16.71 seconds. So this is for one discharge. This is for one discharge condition. Let us change the discharge from the pump supply and find out the discharge as well as head difference. So now open this a little more. So we can see the head difference here. You can see now by changing the supply. So this is now, this is 16, so it is 16.5, yeah, 16.5, and this side it is 28, exactly 28, you can see, or 20, yeah, 28. So it's a 16.5 and 28. That is the second discharge condition, and let us see the discharge. So now let us observe for again 5 to 15 centimeter or 10 centimeter rise from 5 to 15 at this second discharge condition. Yeah, here. So it is now coming to 5. Yeah, here. Yes, 14, 15 and now 11.36 seconds. Now, we should take one more observation. So now let us take the second observation for the second discharge condition. We start from 5, no 6, yeah, 6 to 16. So 10 centimeter rise in 11.6 seconds. In this way, let us take the third observation for 25 millimeter diameter pipe, and by changing, this can be done by changing the discharge further. Now you can see the head difference is changed. So supply side it is 13, 14, so it is near about 13.9, and discharge side it is 30, so 30.6 and 13.9. This is the third discharge condition for 25 millimeter diameter pipe, and let us measure the discharge. So let us go again from 5 to 15, 10 centimeter. Water collection in this tank takes how much time to find out discharge per unit time. So let us start observation from 5 to 15. 5 to 15. Yeah, here 9.02 seconds. So let us take this another observation again from 5 to 15 for second set. Oh, 6, from 6 to 16 this time. So it is going 12, 13, 14, 15, 16, 9.4 seconds. Okay. In this way, we have measured discharge for 25 millimeter pipe, and for you I will observe at least 3 discharge for remain 4 size pipe, 15 millimeter, 20 millimeter, 32 millimeter and 40 millimeter, and will give you the head difference that is measured between inflow and outflow side of the pipe, that is tapped at the length of 2.4 meter. So this observation discharge you can use to find out what is the friction factor of this pipe, that is a steel pipe, for different discharge condition, and based on that you can answer the question whether friction factor changes with respect to discharge condition or pipe size condition, or what is the friction factor. And that is basically measured or estimated by using the head difference, that is head loss due to friction, which is also called major head loss in the pipe system. Thank you. Yes, finish video.
Yes.
Okay. So any query? Any query related theory, process, or anything?
No, sir, no query.
Okay, so this is major head loss. It is called major head loss or friction because of friction. Head loss due to friction, it's a major head loss, usually in pipelines. Secondary loss is because of fittings, and that will be next experiment we will do later on, next week maybe. So no query, no question. You need to submit your records by Saturday midnight. That is, you have taken. Is not that? Okay. And a few of you have not attended Viva. There are 7 students who have not attended basically interaction meeting, and it also has. What about Rahul? B. Rahul. Then Muhammad Abu Qutad Faruqi. Are you there? Haris, V. Haris. All 3 are wearing roll number 2018 batch. Okay. Then it is Hemant Pawan Teja. Are you there? Pawan Kalyan. Who is there? Pawan Teja, Pawan Kalyan. Anybody?
Teja sir.
Teja, you have not attended. Why the meeting?
Sir, I have already mailed you.
Okay. What happened?
Sir, some family issue.
Okay. Teja. Okay. Let me keep you half. So you people need to arrange this. At least one meeting be required. Pawan Kalyan and Prajwal Jha. Prajwal? Not there.
Sir, did you call my name, sir? Sitaram, sir.
सीताराम जी, आप हर समय बिजी रहते हैं नहीं?
Sorry,
Morning
sir.
I called the name and you were busy, then why you were in the class?
Sir, मैंने
No, that is means problem of this online system. No, you people are thinking or suggesting that we should come to the campus and you are not attending class. At least when I am calling, you should be there. You
Sir,
are telling something and 3 times you have rescheduled your meeting as well.
sir, I left the class at 11. Like
You are telling to me. You know it better what you are telling and what it happened really. I am not going to that. That is for sure. I am not going to that. I am not going to find out a levy and correct. I am not a policeman. I am simply a teacher and simply asking to my student whether you are correct. And if you are correct, it's fine. I cannot cross check anybody and everybody. So you were also not present. So you 7, there are 7 students. Sitaram, you, Prajwal Jha, Pawan Kalyan, Hemant Pawan Teja, Harish, V. Harish, Muhammad Abu Qutad Faruqi, B. Rahul. So you people should give me a time now. I will not give you time. I have given 2 days, Monday and Friday last. But because of somebody just like Hemant was having trouble at home or some problem, so it is fine, no problem. But others have not given me any reason why they have not attended. So you need to decide. Otherwise, means at least 1 or 2 marks I certainly will give from my assessment of this meeting. So now give me all 7 collectively. What time you all 7 are ready to meet me, right? So you coordinate among yourself now. Is it
Yes,
okay? You coordinate. I have given you 7 names: 2014, 2016, 2018, and 2019 batch. 7 names are there. Give me one time. I will like to meet you all 7 in a single sitting. That's fine. Sitaramji, and you are the coordinator here now. You also learn the problem of arranging time and asking every time. So you coordinate, bring all you and all other 6, bring in a single time slot to me. Okay?
sir. Can you send me the names? Like I will.
I am sharing here only.
Okay, sir.
Just one moment. I'm giving you. Anybody know this Pawan Kalyan?
Yes, sir. I know, sir.
Oh, you know. But he is batch 2014, is not it?
Yes, sir.
1, 2, 3, 4, 5, 6, 7. There are 7 students. Okay. Here it's list. Can you see this? I sent one text. P. Pawan Kalyan.
Yes, sir.
Hemant.
I got it, sir.
Okay. So 1, 2, 3, 4, 5, 6, 7 students. Okay.
Yes, sir.
So coordinate with all and give me a time. And I asked to get time 2 hours for theory class extra. So please give me time day after tomorrow class. Means tell me the time in day after tomorrow's class.
Yes, sir. Sure, sir.
Okay. And submit your record by
Sir,
Saturday. Yeah. Yeah, please. Rajesh. Yeah.
sir, Google or Ritvik had not sent any file up till now, despite reminders.
Who?
Google or Ritvik.
Go to Ritvik. Let me find out his name in my list first. What is the Google to Ritvik?
He is presently in the
19
meeting.
3008. You he is here.
Yes, sir.
Google to G Ritvik. G Ritvik. See everybody. Ritvik is here. I can see in the list. He has attended. He is attending class. But where is he? Google.
Sir, yes, sir.
Yeah. So how many times should I call your name? Then only you will reply. Answer to me. Eh?
Not like that. I mean,
You are sleeping, your voice, you ask your friends.
no, no.
I'm not telling you, ask your friends what they are telling, how they observe your voice. So why have you not submitted your records? That is the main point that we can discuss others. You have not submitted any record. And at the last, please don't tell me because it's online, so I cannot help you then. Is it fine to you?
Sir, Sir, I will submit, sir. Like,
Why have you not submitted? That is my question. What is the problem? What happened? Everybody got the same time, same opportunity. What is problem to you?
sir, can I tell you personally, like, not in the class directly, but
Okay, but it's you are attending class every time.
yes, sir.
You should also work to submit your.
Sir, actually, he has got some COVID problem in his
Sir,
server.
that was earlier, sir. But
It was
later
earlier.
on, there was some other big issue which happened, which got until Dean. I mean, so I'll tell you personally, sir, regarding that. But keeping all those aside, I don't want to keep those as an excuse, sir. I want to do all the assignments genuinely, and I want to submit. But
Okay, you
it's
please
just taking
submit.
some
Okay.
time. But not only this subject, no, sir, because I have eight subjects parallelly.
Okay,
So
just a bit. And yeah, you keep on telling. Yes, please. Rajesh?
Yes, sir.
So he will submit. He is asking for some time. He will submit. Is not that, Ritik?
yes,
How
sir.
much time? How much time you are asking?
Sir, this week I'll submit, sir. Like
This week. Okay, no
as
problem.
soon as
Rajesh,
Yes, sir.
market he will submit. Okay.
Okay.
Okay. So any other problem? Anybody? No? Okay, then take care and submit your record in time and give some time for your class work and lab work as well. ठीक है? Okay. See you then.